Warning. Warning.
Hey, I'm Bob with Laguna Tools. Around here they call me Router Bob. I'm sure you've watched some of our Laguna CNC videos through the years. Occasionally something very interesting comes across the desk at Laguna and from customers or potential customers for applications. And one that we recently did had to do with speaker cabinet nests. Now, speaker cabinets have machining typically on both sides of the parts. So you have a nest here and you got machining on the back side. Well, when you're doing backside machining, you can actually cut the parts out of the top and then reposition each part individually and do the backside operations. In fact, the cabinet programs call that backside machining. And that's fine until you get a whole lot of parts in the sheet that have backside machining. So that intrigued us a little bit, so we decided we wanted to create a system that would allow you to take the sheet, do all the backside machining, flip it, locate it precisely, and do the front side machining and end up with completed parts. To help you understand this whole concept of backside machining and precise positioning, I've designed a cabinet and we're going to make it on the machine and it'll demonstrate these principles. Before we start machining, let's take a look at the machine we're going to be using today. This is a Laguna Smartshop 2. It's a 4x8. It has a HSD spindle option. This machine also features an 8-position automatic tool changer. You know, people ask us, why do the Smartshops cut so well? And they're typically great edge finishes and very accurate. And I said the answer is real simple. It's the frame. The base frame is all welded structural steel, the same thing they make bridges out of, and all the machining for the precision components are done in a single setup, so everything has to align. We use motion components from the best suppliers in the world. We have precision contoured guide rails on X, Y, and Z axis. We also, if you notice, we use helical racks on the X and Y axis, and those helical racks give you constant mesh on the pinions and the racks, and so it's a really smooth move in the machine. On the Z axis, we use a real large, oversized precision ball screw to handle the weight of the spindle. When you combine all these great components, you get a really fine machine tool, and the Smartshop 2 is the flagship of our CNC router line. The Laguna Smartshop 2 CNCs also feature a universal vacuum table, and they have 6 separate vacuum zones, so you can do special fixturing, and they have T-slots, so sometimes you can do special setups that require that. In our case, we're going to be using flow-through, and I've already got it set up, and we'll talk about that in a couple minutes. There's some special things that I did. When we did the original market research for the development of the Smartshop 2 at Laguna, one of the things that turned up was that potential, primarily shop owners, were very apprehensive about how hard a CNC machine was going to be to use. I think the real concern was, were they going to have an engineer type operator to run the machine? And so we took that very seriously, and we developed a Laguna touch control with that in mind. Basically, if you can text on a phone and use a TV remote, you can probably figure this out. And that seems to have worked out very well for us. You know, the control interface for the user is a touchscreen. That's all you have to have. You have a row of buttons on each side and a touchscreen. That's all you have to know to run it. And we also put in centralized lubrication to keep it real easy to keep the precision components well maintained. Now, before we cut the part, let me talk about one little additional step I added. If you notice, this is double stick tape. I actually put double stick tape around the perimeter of the spoil board itself, the MDF spoil board, because remember, in part of the process, we're going to machine some holes in there for pins to locate the second side, and I didn't want to take a chance of that board moving. Okay, now that we've actually looked at the machine, let's go to the office and let's explore this concept of two-sided machining further. here's a cabinet that has an example of parts that require machining on both sides. It normally happens in partitions, especially in this cabinet where I've got a fixed shelf in the middle and adjustable shelves. So those partitions have machining on both parts. Now, this is a cabinet that the guys needed in the showroom. It's a face frame cabinet. The face frame parts are solid wood, so we won't cut those on the machine. So let's turn those off. And basically, this is our box. And this is built like what we call the Laguna construction method. It's blind dado construction. If we x-ray it, you'll see it. These are unfinished ends, so I've also got holes in the joints so that we can screw it together. But you see, it's really nice. Here's that fixed shelf, so there's dados on this side on this part and this side on this part, and adjustable shelf holes on the back side. So that's what we're going to use. Let's stop and explore something a little bit. I showed you the cabinet in SketchUp. Now, the commercial cabinet programs like Mosaic have a provision for backside machining. They call it backside machining, but maybe you're not using one of those. Maybe you're not a cabinet shop. Maybe you're making something else. Now, what I want to do is I want to take that design from SketchUp and I want to bring it in VCarve Pro, and there's a couple of steps you have to do, and I want to explain those so you'll understand how to do that. First off, this is a face frame cabinet, and the face frame's solid wood, so I'm not going to nest that. So let's just turn that off so it's out of the way. And there's my box. Now, when you first click this, it's all grouped together. So the first thing I have to do is explode it. So I'm just going to right click it and say explode. Okay, now I have the individual parts, so I can pick them. Now, here's what you have to do, and this is very important. If a part has operations on it, so if the part like an end panel has holes in it, if it has dados, you have to treat it separately. If you notice up here where I have the entity information, it says unfinished end. Click the beginning of that and add 2 underscores on the front end. That's how VCarve Pro knows that those operations go with that part. Okay, well, we know that one has it. The end panels both have that, so I'll do that on the other end. All right, what else has holes? All right, there's operations in the partitions, so let's name them that way. You'll see in a minute why I'm doing this. Okay, there's the other partition. Okay, and let's see, now the top, because there's dados in there, it has operations, so let's underscore that. And the same thing at the bottom. So every part that has holes or any kind of operation, we put the double underscores in front. Okay, and then we'll save that cabinet. Okay, when you open up a SketchUp file in VCarve Pro, this screen comes up automatically. Let me go through a couple things so you understand what it's doing. All right, one of the things over here is SketchUp doesn't create arcs. SketchUp basically creates curves as tiny line segments, so they're not true arcs. Well, when VCarve Pro brings this in, it will calculate the arcs and turn those into true arcs, so you want to do that. You also down here, it says keep components starting with 2 underscores. Remember, we did that over in our SketchUp file on the pieces that had operations on them. Together, keep all children of components starting with the double underscore with the parent. Okay, the children are the operations. The parent is the part, the end panel. The holes, the dados, those are the children. So by putting those 2 underscores, that's how VCarve Pro knows that all those go with that part. If you don't do that, all those operations will be out in space. Okay, be sure that you don't click replace outer boundary. Now over here, I'm going to only import visible data on selected layers. Well, think about which layers I want. In my cabinet, my back is a different material thickness, so I wouldn't use that. What's left are the end panels, the interior parts, the top and the bottom, and we hit OK, and there they are. And if you look on the screen, you'll see there's the dados, there's the holes, everything's there. Now, there's a couple things that before I can really do much more with this that I have to do to these files. Now, even though these parts fit on a sheet, we really didn't nest them. Now, there's a couple things that we'll have to do. For one thing is grain direction. Now, what I normally do is these, by the way, these are already grouped together. So if I pick that part, hit it again, I'm going to move it over here out of the way, all right? All right, and I'm going to rotate it 90 degrees so that I get the grain direction correct. And I hit apply. Okay, there, that one's good. Let's do the same thing here. We're just picking the ones we know are obviously need to be rotated, and then we're going to tell it we're going to limit how it can rotate. I'm going to do the same thing here. This happens to be a horizontal member. We want to rotate that. And this one is. And this one is. and this one. Oops, I forgot to rotate that one. Let's rotate this one. Now you really don't have to move them to the side here. It takes care of that, but we'll move them over where they're clear in this last one. Okay. Okay, now let's actually go through the nesting process. At this point, even though it brought them in on the sheet, they're really not nested for yield. So what we're going to do is we're going to open up nesting. All right, if you've never nested before, the first thing says tool diameter. Well, what tool are you going to cut them out with? I'm going to cut these out with a 3/8 compression bit, so the tool diameter is 3/8. I want a little extra room in between them because I'm going to have some lead ends, so I'm going to add 1/10 of an inch. Border gap means how close do you want to place them to the edge of the material. Okay, rotate parts to find the best fit. Well, I'm saying 180 degrees because of grain direction. All right, and I've already straightened them out where the grain directions are all running right. Now, what I'm going to do is put a window around these. I'm going to hit apply, and I'm going to hit preview, and they're nested on the sheet. It's that simple. That's all it takes. And now those are nested for yield. Now there's a couple other little things you're going to have to do before you're really ready to toolpath these, and let's look at that. Now when the operations come in, and by operations of course are holes and dados for instance, the geometry represents the physical shape, but we've got another consideration when we route, and that is the radius of the tool. So if I'm going to cut a dado and a piece fits in it, I have to make that dado a little bit bigger. In our case, we're going to cut the dados out with a 3/8 down shear, so those need to be 3/16 bigger on each end. So let me show you how to make those changes in VCarve Pro. It's really simple. First, when these are brought in, they're grouped together. So I need to ungroup it. So I'll just ungroup that. Now, once I do that, I can select that geometry, okay? So now we want to resize it. I'm going to show you an easy way to do that with VCarve Pro. Hit this button that allows you to resize. Make sure the anchor button is in the middle because that's where it's going to stretch it from. Make sure the link XY is not checked because it keeps it proportional if you do that. Okay, well what do I need to change? I don't need to change the height because that's the material. What I need to do is I need to add some on here. Well, I could get a calculator or I can do it this way. Okay, there's the number. It says the width of that dado is 7.498 inches, right? So I'm going to say plus the tool diameter, because half the 3/8 is on each end, plus 0.375, right? Now hit equal and enter, and VCarve Pro calculate that for me. All I had to know was the tool size. That's a great tip. Two of these parts have machining on the back side, and that happens to be the partitions. Okay, what we're seeing on the screen here is the actual nest of parts, and I've got it set where we're looking at the back side, okay? So what do we really need here? Well, the only thing we're going to machine is we're going to machine two things. We don't need these parts. All we really need are these two dados. That's all I have to cut. And you'll see I've added another piece of geometry, which is, it's really an enclosing rectangle, but it's a little bit larger than that. And the idea is accuracy, and here's what you get into. First off, I'm going to put the sheet on the table and get as accurate as I can. Okay, by cutting those two dados and cutting that perimeter, the relationship between that shape and those two dados is a machine accuracy, which would be less than 1/1000 of an inch. So that factors out any inaccuracies that I have in positioning, so that's the first step. Okay, now what I've done on this particular drawing is I've taken the original drawing, the back side, and I've mirrored it. Because think about the geometry changes, so I've mirrored it. Now, you see all the geometry. Now, I don't need these dados that are back side because they're already cut. Now, what you see are the parts, and you see this shape. So our true part shape is actually this red line. Now, I'm going to add another little operation, and I'll show you what it is. If you notice on here, I'm going to have another program, and all it does is drill 4 1/4-inch dowel holes. And there they are, 1, 2, 3, and there's one up here. All right, now here's where they fit. Here's the boundary, so the boundary is actually, this is the shape of the part we have left. See how that locates them? All right, those form a corner that part goes in, or the blank goes in, and that's what makes the front align to the back, and that's why this system works. Okay, now let's turn our parts back on. And I'm just turning layers on. We'll turn our back side off so we don't get confused. Now, That's ready to be toolpathed. So our next step then is we're going to create 3 programs. One is the back side that we're going to run first, then we're going to run our program to do the pinholes, and then we're going to do the other side. And when we run those, we should get our parts with the backside machining correct. Okay, here's what we've got. This is the back side. This is what we're going to run first. Let's go to simulation. Okay, now the first thing we're going to do is we're going to cut our dados, and you'll see them, and then we're going to cut the perimeter of the part, the outside. And if we double click that, then that's the result of our first nest. It was that simple. So we've created the backside machining, which are the 2 dados on the partitions, and we've cut the perimeter, so now that accuracy is built in. Okay, now after we've flipped our material on the machine, let's look at the tool paths that are going to be applied there. The first thing we're going to do is drill our pinholes. So this will be done before we put the material on, and then we'll put our dowel pins in, and that gives us our location. So that's what this tool path does. We should be able to see it on the screen faintly, okay? Then we'll put our material on there, and we'll drill our 5mm through holes. And remember, those are to give us the ability to assemble the cabinet with screws, really, because our end panels are unfinished. Okay, then while we have the 5mm drill, we'll drill our line bores. So those are adjustable shelf holes, okay? Then we'll do, now this next concept, let me expand on this a little bit, because this is how the cabinet programs do it. Okay, so here's what we use. We use a concept called return onion skin, and here's what that means. We deal with small parts a special way on these machines because the surface area on a small part is not very large sometimes, and they tend to want to move around. So we say, well, when I cut those parts out, I want to have as much vacuum as possible available. So the first thing I do is I say, I define what are the small parts. In our case, they're going to be those shells, the small pieces. And what we're going to do with each of those is we're going to cut them out, but we're going to leave about 30 thousandths. That's the onion skin. So most of the force required to machine those is gone, yet they're still connected. So that's called the onion. And that's what this is going to look like. So let's simulate that. Now those are the small parts, and I arbitrarily said small. A cabinet program typically would say anything under 144 square inches or a part that's 5 inches or narrower would be counted as that. Okay, then we're going to return back to those parts, the small part, and we're going to cut them through. Okay, so that's called return. So that's where return onion skin comes from. Okay, now, so we've dealt with our small parts where we had the maximum vacuum first. Now we're going to cut the outside parts of it, the large ones. And that's what final. And we get rid of our scrap, and I think there's a scrap piece there. And there's our parts. So that's how this is going to work. So we actually use the same tool pathing system that you would use with Mosaic or Cabinet Vision or one of the cabinet programs. We're ready to make a cabinet. Let the machining begin. Well, our first sheet came out really nice. The dados came out good. They're right where they're supposed to be. We've got a really nice edge finish on this, so far we're successful. By the way, make sure you flip the sheet in the right direction or your backside machining and your front side machining won't line up. Well, the adjustable shelf holes look good. Well, the cuts came out really good. The edge finish is just magnificent. I mean, you can't ask for anything better than that. It's funny, these Smartshop tools will cut as good as a CNC that you might pay 3 times as much for. We're using the same components, so that looks really good. The joinery is nice. I like this Blindado joinery. That's really nice. All right, but you know, the real test is, do our partitions have dados on the back side? Let's check. I know this is a partition because I can see where it fits down in the joint at the top and bottom. Here's the holes. Let's see what's on the other side. All right. And it looks like this is about the equal to that, so I think we've got a good part. And let's check the next one. I can't tell you how important it is to flip the board correctly. Let's see what, this is the other partition. Yep. Let's see if this thing fits. Oh wow, that fits perfect. Our allowance was dead on. Wow, that really worked. Well, our test cabinet came out really well. All the joinery was perfect, just like we expected. And of course, these edge finishes you expect on a Smartshop too. That's just how it is. But you know, our real test on this was to create a system that we could machine back sides, and that's what we did. These are the partitions. Those were the dados. If you notice, our shelf is lined up perfect. Had those been off, you could see it in that shelf. And of course, we have our adjustable shelf holes on both sides. This came out really, really well. Well, I hope you enjoyed the video. It came out great. We wanted to test an idea of how to do backside machining on nested parts. We also wanted to demonstrate the connection between SketchUp and VCarve Pro. And along the way, I also wanted to explain how you hold small parts, and we did that with return onion skin. So we really solved a lot of problems in this video, and I hope you really enjoyed it. If you have more questions, please call us at 1-800-234-1976, or you can visit lagunatools.com on the web. Thank you for watching.